And then this. So one of my themes, I started out lecture 1, the simple universe. Remember that universe? It was just galaxies. There was no microwave background. There were 2 numbers to measure. And look where we are today. So we've got matter, 27.3%. It's, oh, that's baryon is a fancy word for atoms. So atoms, 4.6%. Neutrinos, we still don't quite know how much, but a few tenths of a percent. Cold dark matter, 23%. Then we have radiation. So that's the microwave photons, but also there's some neutrinos around. And then we have dark energy. And this is II Rabi. And when the muon was discovered, the muon's a heavy version of the electron. Rabi famously said, "Who ordered that?" You know, why, we don't need that. And I remember when I was always looking for order, when I was in high school, I loved the idea of neutrons, protons, and electrons. And in fact, I had a secret theory that the neutron was actually a proton and an electron. And that's perfect. 2 basic particles. But we have many, many more than that. Why is the universe so complicated? You know, why isn't it a simple one of those Julia Child 15-minute recipes? And it's real complicated. Why that? Oh, yeah. So this was promised before the Big Bang. I said this is now within the realm of science. And here's my disclaimer. I'm going to talk about 3 ideas. All of them are probably wrong. So the real message here is that we can now formulate it as a scientific question. And that's step 1. That's step 1 to making progress. And so here we go. Let's start with Einstein. So this is the Big Bang Theory. Not the TV show, but what I've been telling you about. And let's see. Here's the Big Bang. The universe is getting bigger. There's the quark soup. There's the neutrons and protons. There's the formation of galaxies. Everybody get it? And here's the Big Bang. And according to Einstein, according to Einstein's theory, the Big Bang was the singular creation of space, time, matter, and energy. And so the question, what happened before the Big Bang, doesn't make sense, because that was when time was created. Now there's a couple of flies in. Let me speak to the elegance of this solution. So this is a very elegant solution that actually came before Einstein. Does everybody know St. Augustine? So people actually met St. Augustine? So he was asked this question, and he pondered it. He was not only, he was a philosopher among other things, and his first answer was he created hell, for those who had asked that question. But his second answer was a more thoughtful question, which was God created time along with space. Because it doesn't make sense to just be sitting there for eternity and then suddenly... so really, it logically, I'm not trying to put a religious bent on this, but logically it's very beautiful. But remember about beautiful theories and ugly facts. And so, but there's a technical problem, which I mentioned earlier, which is Einstein's theory has 2 defects. Defect number 1 is it wasn't invented by me. No, just kidding. Defect number 1 is it has infinities in it. Now you all remember, an algebra teacher who had you divide 1 by 0. Actually, probably the young people, they didn't even have to. They just punched it into the calculator, and 1 over 0 doesn't make sense. And so a singularity is an infinity, something that doesn't make sense. So the idea of laws of physics is that, they're not just suggestions, and they should hold everywhere. And so a theory that predicts singularities or infinities is incomplete. Of course, that could just be the way things are. And the second problem is that it doesn't incorporate quantum mechanics. And for those two reasons, we strongly suspect that Einstein did not get the last word on gravity. So then you might say, oh, well then why should I believe any of the stuff you were telling me based upon general relativity? Well, it turns out that for most of the history of the universe, the singularities and the lack of quantum mechanics, you can show that they are not an issue. But right here, that's where they would be problematic. So right where it's talking about no before the Big Bang is where the theory is most suspect, where you should trust it the least. Everybody with me on that? But that's Einstein's answer. So there is a theory that would like to unify gravity with quantum mechanics. Oh, I'm slightly ahead of myself here. So what I wanted to say, because this is another wonderful thing about science, is sometimes you can get the right answer for the wrong reason. And so you don't want to forget that. And there is a theory, especially when it's such a good answer, that might actually address this, or that hopes to address this, which is string theory. And string theory is either the theory of everything or the theory of nothing. It's kind of one of those one of those high-risk things. And one of the features of string theory that I think everybody knows is that in string theory, they're not just the 4 dimensions, there's probably 6 or 7 other dimensions. So one of the things that happens in string theory is dimensions come and go. And so one of the things, one of the features of string theory is that space and time, I'm not going to explain this because I don't understand it, may actually not be fundamental, but may be an emergent phenomenon. Which is, almost impossible to get your head around. But boy, would that fix up this picture. Right? Space and time emerge from what? I don't know. So maybe that's what happened, is that the Big Bang is the emergence of space and time, to be explained by string theory later. Okay, another idea is the multiverse. Oh, and I had to take aspirin before this talk because I always get a headache when talking about the multiverse. So this is sort of another direction you can go with getting rid of the Big Bang. So this is a Monet painting. So this is the River of Time. This is the Big Bang wedge. And we talked a lot about inflation. And so if inflation is correct, then what we thought was the capital B, Big Bang was our little Big Bang. And so this could be us. So there was one little thing that I didn't tell you about inflation. The equations say that if inflation happens once, it happens a few times, where a few is an infinite number of times. And so inflation strongly suggests that the universe should look like this. Bits of space exploding, and so there wasn't one beginning, there weren't 2 beginnings, there were an infinite number of beginnings. And so it makes moot the point about a beginning, or at least distracts you. But there's more. And the more is that according to these equations, these little inflationary explosions, these little inflationary patches, these little different universes are distinct and can't communicate with one another. So they're causally distinct. Okay. Ooh. And so that starts to, it's interesting. So this would one-up Hubble. Remember, he enlarged the universe by 100 billion. This enlarges the universe by, but there's more. And the more is, what the heck? Why not marry this with string theory? And so if you marry this with string theory, these different inflationary bubbles might have different laws of physics. And by different laws of physics, I mean like different numbers of dimensions, and some of them don't have stable, don't have neutrons and protons and us. And so this is a lot to think about. And so we only think about it when drinking multiverse beer. So is there anyone in the room, I will allow you to come up and finish my lecture if you're willing to say, this isn't a big idea. it's a really big idea. But the problem is it science? So how do you test this? And these different pieces of the multiverse don't communicate with one another. So how can you verify their existence? On the other hand, how can you not think about this idea? If this idea is correct, this is bigger than Copernicus. And I apologize to, I don't know if he's here today, but a Polish member of our audience. So I'm saying this with great respect to Copernicus. And this is a big deal. But it might not be science. And, you know, but let's see. Yes, I wanted to remind you, just because that's where we started today, we can test whether or not we began from inflation. Let me also, just a disclaimer here before you go home saying that I said there was a multiverse, because that's not what I'm trying to say. So let me just go back here. So the equations that we use to describe inflation, I know one thing for sure about them. 100 years from now, people will say, oh, they were, you know, that, my goodness, how could they have been so stupid? And so we may be taking the equations too seriously. Sometimes we don't take our equations seriously enough. Like Gamow, had he followed things a little more carefully, could have really predicted the microwave background temperature. So this is a real dilemma. So no Big Bang, or lots of Big Bangs. Sorry, no beginning, lots of Big Bangs. And then the final one that I mentioned, because again we can write down mathematics to describe it, is the brane world of string theory. So string theory has all those extra dimensions. What do you do with them? Lots of things you can do with them. One is you can roll them up and make them small so you can't see them. Another is that you can say, well, you know what? They're there. You're just too dumb to see them, in the following sense, that we live on a brane and we're like vibrations of this brane, like vibrations on a drum head. And so since we're vibrations on the brane, we have to be on the brane. And so the larger space is filled with all these branes. And if it's filled with all these branes, can't they collide every once in a while? And if they do collide, can't you have, and people just love the bouncing universe, the cyclic universe. I call it the bouncing universe because I don't like it that much. But so, you know, the branes collide, and then they pass through one another and collide again. And what's wonderful about this picture, for just to, is that string theory will allow you to calculate this. Would allow you to calculate this. And moreover, what people like about the cyclic universe is that you remember in a few trillion years, I forgot to mention this. Actually, Freeman Dyson mentioned it in his lectures. All the stars will be gone, and so we have a dead universe. So this is like a reset. You know, the universe gets refreshed every once in a while. And somebody's going to say, gee, I heard about that a long time ago because this is Einstein's closed universe. And, well, not quite, because in his closed universe, this was, all you heard was you heard a exploding sound here and a sucking sound here, because these are both singularities. So you can't, the bouncing part doesn't exist. So again, this is kind of a patch on Einstein's recollapsing universe.